Now, assuming that the firing angle is 30 degrees, that is alpha is equal to 30 degrees. Now we will see how the output waveform will look like. So this is the waveform that I have already drawn, but let me check out how mathematically we can prove that is the right waveform. So if I am telling alpha is at 30 degrees, okay, firing angle is at 30 degrees. So firing angle is at 30 degrees means what will be the omega t? Omega t will be always 30 plus alpha, isn't it? So 30 plus alpha means 60 degrees. So at omega t is equal to 60 degrees, okay, what will be the output voltage of the converter circuit? So when the firing angle is 30 degrees, that is omega t is equal to 60 degrees, what will be the thyristors that are conducting? T1 has been triggered at 60 degrees, and prior to T1 already T6 will be conducting, isn't it? So if T1 and T2 are on, so look at the diagram. If T1 is on and T2 is on, what happens to the load? Load is connected, the positive of the load is connected to the R phase and negative of the load will be connected to T6, okay, T6 which is connected to Y phase. So V0 will be nothing but Vrn minus Vyn. This will be the output voltage, isn't it? So what is Vrn? Vm sin omega t. At what omega t now you want to find out? At 60 degrees. So put sin 60. So Vm sin 60 will be nothing but root 3 by 2 Vm, isn't it? Minus Vyn. Vyn is Vm sin omega t minus 120. If you put omega t is equal to 60 degrees, 60 minus 120 is minus 60. So that will come out to be minus root 3 by 2. So this will become root 3 plus root 3 by 2 Vm. So finally you will get at omega t is equal to 60 degrees, output voltage will be root 3 times the maximum voltage. That is nothing but simply I can say 1.7 times the maximum voltage. So this point corresponds to 1.7 times the maximum voltage, okay, at 90 degrees. So anyhow, after T1, what are the thyristors that are conducting all through? So T1 and T6 are conducting at 90 degrees also, because at 90 degrees still R phase is the highest and already the Y phase has been negative for a long time. So it will continue to be negative there. So the output voltage will be at omega t is equal to what? 90 degrees. Vm sin 90, that will be Vm. For Vyn, Vm sin omega t minus 120, omega t is equal to 90. 90 minus 120 is minus 30. So that will come out to be minus 1 by 2. Here it will become plus Vm by 2. So finally you will get output voltage will be 1.5 times of Vm. So this part is nothing but, this point is nothing but 1.5 times of Vm. At 120 degrees, T2 has been triggered. Before T2 has been triggered, what was the conducting pairs? T1 and T6 are on. So if you put omega t is equal to 120 degrees, okay, then you will get sin 120 degrees is root 3 by 2 and Vm sin omega t minus 120. Wow, omega t is equal to 120 means this will become 0. So that will be root 3 by 2 Vm. So in decimal it will be 0.86 times of Vm. So if you see this point, this is the lowest point, this is equal to 0.86 times of the maximum voltage, okay. But at 120 degrees, T2 is also triggered. If T2 has been triggered, what are the thyristors after 120 degrees, or what are the thyristors that will be remain conducting from 120 degrees onwards? So T2 will be there and T1 will be there, because at 120 degrees still R phase is the highest, therefore the conducting will be T1 and here VR, and in the negative group B phase is the highest, isn't it? Therefore T2 has been triggered. So T1 and T2 are conducting now. So if T1 and T2 are conducting, then output voltage will be nothing but Vrn minus Vbn now. So if you put omega t is equal to 120 degrees, then you will have root 3 by 2 Vm minus, put omega t is equal to 120 degrees in Vbn. So 120 minus 240 will be minus 120. Minus 120 will be minus root 3 by 2. That will come out to be plus root 3 by 2 Vm here. So you will get again root 3 Vm, that is 1.7 times of Vm, that is maximum voltage. So at 120 degrees only, again you will have 1.7 times of Vm. That means I can tell there is a discontinuity at 120 degrees. One is due to T1 and T6 and other one is due to T1 and T2. That means there is a changeover from T2 to T6 in the negative group. Okay, in the negative group, earlier T6 was conducting. Now this current has to be transferred by T2. When T2 has taken the current, then the voltage value has been increased suddenly. So that is what we say, there is a discontinuity there. But anyhow, overall if you see, the voltage is continuous only still, because it is not becoming 0 for a finite duration. So in this fashion, the cycle will prolong and you will be getting a waveform of this fashion. Okay. Now what I will do is, I will try to increase the alpha further by 30 degrees. Then I will make alpha is equal to 60 degrees. When I make alpha is equal to 60 degrees, T1 will have been triggered at 90 degrees, T2 at 150 degrees, T3 at 210 degrees, T4 at 270 degrees, and T5 at 330, and T6 will be 390, or in other words I can tell it will be triggered at 30 degrees also. Okay, so this is also T6. Now we will try to understand the operation when you are making alpha is equal to 60 degrees. So we will try to analyze the output voltage waveform for alpha is equal to what? 60 degrees. When alpha is 60 degrees, where will the omega t will be? Omega t, as you know, it is 30 plus alpha, so it will start for 90 degrees. Okay, now at omega t is equal to 90 degrees, I have to analyze what will be the output voltages. So at 90 degrees, okay, at 90 degrees, what will be the switches that will be forward biased or will be ready to conduct at 90 degrees? If you see, T1 is ready, always high, so that means R phase is always high, therefore T1 will be conducting. And just before 90 degrees, see who was least? B phase, isn't it? So I can say at 90 degrees, okay, T1 and T6 will be conducting. Okay, T1 and T6 will be conducting. If T1 T6 is conducting, V naught, you know, that is Vrn minus Vyn, and if I put omega t is equal to 90 degrees, then what will Vrn will be? Vrn is Vm sin omega t, that will be Vm minus Vyn. So if you put omega t is equal to 90 degrees in Y equation, then you will get 90 minus 120 will be minus 30, minus of minus 30 in sine will be minus 1 by 2. Here it will become Vm by 2 plus Vm by 2, that will come out to be plus 1.5 Vm will be the output voltage at 90 degrees. So I got some output voltage at 90 degrees as plus 1.5 times of Vm. Okay, this is 1.5. So after 90 degrees, okay, after 90 degrees, anyhow T1 has been triggered, and which switch will be conducting at after 90 degrees? After 90 degrees, if you see the positive wave, okay, T1, that is R phase is always higher than the others, and if you see which is more negative, B phase is more negative. B phase is more negative means after omega t equal to 90 degrees, T1 and T2 will be short circuited or will be conducting. Then output voltage will be nothing but Vrn minus Vbn, isn't it? So if you put omega t is equal to 90 degrees, this will be Vm only. In Vbn put omega t is equal to 90. So 90 minus 240 will be minus 150. Sine of minus 150 will be equal to 1 minus 1 by 2. So here also again you will get Vm by 2, that will be 1.5 times of Vm. That means if you take T1 and T2 are conducting, or T1 and T6 are conducting at omega is equal to 90 degrees, both voltages you are going to get the same. So I just wrote this one also to avoid that confusion that some students might be having generally at this point of discussion. Okay, now let us look at next voltage, next angle, that is at 90 degrees. What will be the voltage? So put omega t is equal to 120 degrees. So anyhow after 90 degrees T1 and T2 are conducting, so output voltage will be Vrn minus Vbn only. So Vrn, so sine 120 degrees will be root 3 by 2. So root 3 by 2 Vm minus Vbn. If you put omega t is equal to 120 degrees, 120 minus 240 is minus 120. Minus 120 will be root 3 by 2. Again you will have root 3 by 2 Vm plus root 3 by 2 Vm. This will come out to be 1.7 times of Vm. So the output voltage will have increased to root 3 times. Okay, that is 1.7 times. It has increased at 120 degrees. Okay, at 150 degrees, let us see what happens. So again at 150 degrees, just before 150 degrees, anyhow T1 and T2 will be conducting. But that means if this is 150 degrees, before 150 degrees T1 and T2 are conducting. After 150 degrees, at 150 degrees who is triggered? So in this converters topic, you should be clear with one thing, that is Thyristors conduction angle. That one should use, that is Thyristors on time, T on, will be for always 120 degrees once they are switched on. So if T6 is switched on at 30 degrees, then it will be on for next 120 degrees. 120 degrees means 1, 2, 3, 4. So up to 150 degrees, T6 will be on. And see, T1 is on at 90 degrees. If T1 is on at 90 degrees, for the next up to 210, it will be on up to next 120 degrees, isn't it? So up to 180 degrees, T1 and T6 will be under conduction. So we will find out the next voltage at omega t is equal to 120 degrees and 180 degrees also. At 120 degrees, Vm sin omega t, sin 120 is root 3 by 2 Vm, and 120 degrees if you put here, then you will get 0 minus 0. So you will have 0.86 times of Vm at 120 degrees. So at 120 degrees, the output voltage has been reduced to 0.86. Okay. So now the next angle is omega t is equal to 150 degrees. Okay. At 150 degrees. So at 150 degrees, anyhow T2 will be triggered, but before up to 120 to 150 degrees, T1 and T6 are conducting. So the output voltage will be Vm sin 150. Vm sin 150 is Vm by 2 minus Vm sin 150 minus 120. 150 minus 120 will be 30 plus 30. So Vm by 2 minus Vm by 2. So output voltage will become 0 at 150 degrees. So this is the output voltage. So if I will draw the waveform of output voltage, it became 0 like this. But at 150, T2 has been triggered, and who will be conducting at the instant after 150 degrees. So if you say this is 150 degrees, okay, this line is 150 degrees, just before 150 degrees T1 and T6 will be conducting, and at 150 degrees T2 has been triggered. So after this T1 and T2 will be taking over the conduction, because in the negative group, if you see, T6 has already completed by 150 degrees, its 120 degrees conduction has been completed. So the next hero is T2. So T6 will transfer all its current to T2, and T1 still did not complete its term. So T1 and T2 will be conducting after 150 degrees. So if T1 and T2 are conducting after 150 degrees, the output voltage will be nothing but Vrn minus Vbn, because T2 is connected to which phase? It is connected to B phase. So at omega t is equal to 150 degrees only, what will be the output voltage due to T1 and T2? So Vrn at 150 degrees is anyhow Vm by 2 minus, in Vpn put omega t is equal to 150. So 150 minus 240 will be equal to 90 degrees, minus 90 degrees. So Vm sin minus 90 degrees will be minus Vm. So this will come out to be Vm. So that will be equal to 1.5 times of Vm. That means suddenly the voltage has been shifted to 1.5 times, that is on the top like this. So in this fashion, if you observe the output voltage waveform, it looks like this only. So this is how the output voltage waveform is. Now here at 60 degrees, now you see it is at the boundary of discontinuous and continuous conduction, isn't it? Because the output voltage has just become 0 and it is suddenly rising up to 1.5 times of Vm. So this is when alpha is equal to 60 degrees. I will further extend alpha by 90 degrees and I will see. Now if alpha is equal to 90 degrees, if alpha is equal to 90 degrees means where will be the triggering pulses? So the triggering pulses will shift again by further 30 degrees. So for T1, the firing angle will be given at omega t is equal to 30 plus alpha. So alpha is how much? 90 degrees. So 30 plus 90 is 120 degrees. So at 120 degrees onwards, the firing pulse will have been started for T1. So this is where T1 will get its triggering pulse. And again 60 degrees later, T2 is triggered. At which angle? At 180 degrees. This is 180 degrees. This is 120 degrees. At 240 degrees T3 and at 300 degrees T4 is triggered. And at 360 degrees T5. That means at 0 degrees also T5. Again 60 degrees later T6. So for one complete cycle, this is the sequence of triggering pulses for alpha is equal to 90 degrees. And again, as I told you, always in a converter, the switches will be conducting for 120 degrees. That means if at 0 degrees T5 is triggered, that means up to 120 degrees T5 will be on. Okay, up to 120 degrees T5 will be on. So T5 will be on up to 120 degrees. 60 degrees T6 has been triggered. If T6 is triggered at 60 degrees means up to next 120 degrees, that is up to 180 degrees, that is up to here, who will be on? T6 will be on compulsory. And again at 120 degrees T1 has been triggered. That means T1 will be on up to next 240. That means up to next 120 degrees T1 will be turned on. At 180 degrees T2 has been triggered. So T2 will be on for the next 120 degrees, that is up to 300. So this will be T2 time period. At 240 degrees T3 is turned on. So up to 360 degrees T3 will be conducting, or T3 will be on. At 300 degrees T4 is turned on. So up to next 60 degrees like this. Okay, T4 will be on, T4 will be on. Okay, so now we understood which thyristors are conducting at which time periods, isn't it? So now we will try to make the waveforms starting from T1. Okay, so T1 is triggered at omega t is equal to 120 degrees. At omega t is equal to 120 degrees, what are the thyristors that are conducting just before 120 degrees? T6 is conducting. At omega t is equal to 120 degrees, T1 has been triggered. So I can say T1 and T6 are the operating switches at T1 triggering time, that is at 120 degrees omega t. So the output voltage is, as you know, again Vrn minus Vyn. Vrn is Vm sin 120, that will be root 3 by 2 Vn minus Vyn. If you put 120 minus 120, that will become 0. So this will become 0. So that will become 0.86 Vm. So immediately upon triggering at 120 degrees, how much you are getting a less voltage, that is 0.86. Let us look at the next time period, that is at 150 degrees. So this is 150 degrees. Okay, this is 120 degrees. Next is 150 degrees. So at 150 degrees, T6 and T1 are conducting. So same equation will be valid. So Vm sin 150 will be Vm by 2 minus, here in Vyn put omega t is equal to 150. So 150 minus 120 is 30. That will become Vm by 2. That means total voltage, output voltage will be equal to 0 at omega t is equal to 150 degrees. So at 150, the output voltage has been reduced to what? 0. Again at 180 degrees, up to 180 degrees, T6 and T1 were conducting. Okay, T6 and T1 were conducting. So we will put omega t is equal to 180 degrees. If you put omega t is equal to 180 degrees, Vrn will become 0 because Vm sin 180 is 0, and put 180 in omega t in Vyn. So 180 minus 120 will become 60 degrees. So minus of Vm sin 60 will be root 3 by 2 Vm, that is minus 0.86 times of Vm. So this will be some minus 0.86. So the output voltage has become negative. Suppose if the load is RL only, then only the output may become negative. Otherwise, if it were a R load, it will not go negative, isn't it? That thing we have already seen while discussing about half wave converter. Now let us assume that this is RL load, and we will think that output has gone negative. But at the same 180 degrees instant, T2 has been triggered. So there will be some discontinuity, isn't it? Because current has been shifted from thyristor T6 to T2. That means output voltage will be Vrn minus Vbn. Then if you put the value of omega t is equal to 180 degrees, we will see what happens. 0 minus omega t 180. 180 minus 240 will be equal to minus 60. So this will be equal to plus root 3 by 2 Vm. That means plus 0.86 Vm. That means immediately the voltage will rise up to again here 0.86. So this is the type of discontinuity. So if you observe how the waveform will be like, means it will be like this. So this is how the output voltage waveform will look like. Suppose if it was a R load only, if it was a R load, then the output voltage would be 0 again for some finite duration. Okay, for up to 30 degrees, the output voltage would have been 0 for R load. So like we have done for the previous converter, we can make out some conclusions here also, isn't it? So what are the conclusions? Means up to alpha less than or equal to 60 degrees, output voltage and output current are continuous for any load. The load may be R or RL. If alpha is greater than 60 degrees, then the continuity depends upon the type of load. If R only is there, only R load is there, then you will have a discontinuous conduction mode, DCM. If an inductive load is there, you will have continuous conduction mode. And there is one important observation. At any point of time, number of switches that are conducting or on is 2. So this point will be asked in competitive exams. So because this was a full wave rectifier, we are having number of switches that are on or 2. But earlier, if you remember, in half wave rectifier, at any point of time only one switch will be on. And what is the boundary for continuous and discontinuous? Alpha is equal to 60 degrees. Whereas in a half wave rectifier it was 30 degrees boundary for continuous and discontinuous conduction. Now we will see the output voltages for alpha less than or equal to 60 degrees. So for alpha less than or equal to 60 degrees, how the output voltage is following? So if you look at these waveforms which are less than 60 degrees and up to 60 degrees, if alpha is the triggering angle, so the conduction have started from 30 plus alpha and it has been going up to 90 plus alpha. So therefore I can define the limits of integration also. So output voltage V average will be equal to from 30 plus alpha to 90 plus alpha, and the time period of output voltage is, so what is the time period of output voltage? Time period of output voltage will be 6 times less the time period of the input voltage, that is 2 pi by 6, because this is a 6 pulse converter. So 1 by 2 pi by 6 integration from 30 plus alpha to 90 plus alpha, and here the voltage will be Vry, because the output voltage is a line voltage, I told you already, into d omega t. So upon solving that, you will get 3 root 3 Vm by pi into cos alpha. Suppose if you want to write this in terms of line voltage, then it will be 3 root 2 times of line voltage by pi cos alpha. So this is the average output voltage. So the average output voltage which you got here is nothing but it is twice the average output voltage which you have got for a half wave controlled rectifier. Okay, it is just double the half wave rectifier. That is the average output voltage. So this equation is valid if alpha is less than or equal to 60 degrees for R load and for any alpha if it is RL load. Okay, because for RL load always it is continuous conduction mode only. Next we will find out the output voltage for R type load only and for alpha greater than 60 degrees, that is discontinuous conduction mode, DCM mode. So output voltage has been existing, the time period is same 2 pi by 6. We will see the limits of integration. So thyristor T1 has been triggered at some angle 120 degrees and it is becoming 0 at 150 degrees, isn't it? And after 150 degrees, because it is R load, if you are taking R load, it will become 0. So the limits of integration will be 30 plus alpha to 150 degrees and again line voltage VRY into d omega t. So upon solving this you will get 3 root 3 Vm by pi 1 plus cos 60 plus alpha. And again I told you always the thyristor conduction angle is for 120 degrees in all converters. So IT average will be I0 by 3 and thyristor current RMS will be equal to I0 by root 3. So next we have to see what is the source current, average source current IS average and IS RMS. So if you see in one cycle how many times the source is supplying the current. So for one cycle of input means up to 360 degrees. Okay, so let us say this is 360 degrees, up to this 360 degrees. In this 360 degrees, see T1 is on for how much duration? 120 degrees duration. Again the same phase is on for how many duration? 120 degrees. 120 degrees. Why? Because T1 and T4 belong to the same phase, isn't it? So the total time for one phase, per phase the source is supplying in the total time period, how much time it is supplying the source current? For 240 degrees, 120 plus 120. So I can write down IS average will be I0 times of 240 degrees by 360 degrees. So that will come out to be 2 by 3 times of I0 and RMS current will be simply root 2 by 3 into I0. Another important data is the distortion factor for this kind of a converter. So by applying Fourier analysis, then we will find out the distortion factor will be something like 3 by pi. So if you want to find out the input power factor, then you need displacement factor. So displacement factor will be cos alpha into 3 by pi. So this will be the input power factor and distortion factor formulas. These are sometimes important with respect to this kind of converters. Okay, thank you for watching.